Hey everyone, welcome to a relaunch of the Synthetic Dreams channel. I've periodically used this place over the years to showcase some projects I've been working on, but I thought it'd be a lot of fun to kind of shift gears a little bit and start making tutorial videos. So, through my work and personal projects, I've been lucky enough to get exposed to a few different areas in computer science, not just general programming, but some specific topics, things like bioinformatics, or visualization, or hardware design. There was a lot of trial and error involved in learning those things, so hopefully I can help you avoid some of those same pitfalls that I experienced. So without further ado, let's jump into today's tutorial. I wanted to start out with a bioinformatics topic, because I remember when I first got into the field, I was very overwhelmed by the amount of software out there. I had so many questions about what I should run, how it worked, all the command line options. It was very overwhelming. Today, I'd like to talk about using Paladin to characterize your metagenomic sequence data. But before we delve into the details, I think it's important to talk about terminology, since a lot of this vocabulary can differ heavily depending on the context in which it's being used. Metagenomics is one of those words. In our case, we're talking about characterizing shotgun sequence data as opposed to amplicon data like 16S or ITS. There are some really great tools out there for characterizing amplicon data, packages like Chime. But what Paladin allows you to do is to align reads from coding sequences, thereby building a functional characterization of your data. This is great when you've got whole metagenome shotgun sequence data from your microbial communities and you want to know not only what's in there, but what's the function of what's in there, what does it do. To accomplish this, Paladin is going to align your reads to a protein database, such as the Uniprot UniRef90. And when we talk about alignment in this context, we really mean that it's going to search that protein database for the best match to the amino acid translation of each read in your samples. Ultimately, the tool is going to be able to tell you where each read came from. For instance, this read came from an E. coli RNA polymerase gene, or this one came from a C. diff elongation factor gene. And it not only reports this information per read in a SAM alignment format, but also groups and aggregates the data into a table and reports things like abundance, database cross-references, and other useful downstream information. Okay, so let's take a look at the installation process, how to run Paladin using your reads as input, and what the output looks like when you're done. Okay, so before we can start using Paladin, we will have to install it. Paladin is Linux and Mac compatible, so if you're running Windows, you're going to have to install a Linux virtual machine, or you can try using the Linux subsystem for Windows. I haven't tried it, but you might have luck with it. So I'm going to include a link to my GitHub page in the YouTube description, so you can download from that. We're going to do a git clone command. That's what we're going to do to download from the Git repo. I'm going to put in the URL. Okay, so now the Paladin installer is downloaded, all the source code. So we're going to go into the Paladin directory, and you're going to see the source code there and some sample data. We're just going to issue a make command. It's going to go through and compile all the source. If you do run into a problem at this stage and you get any errors, please leave a comment down below or reach me on the GitHub page and we can try to solve it and see what's going on. So if everything's successful, it shouldn't report out any errors. You should be back at the command line here. And if we do an ls now, you should see Paladin as one of the files. That's the newly created binary executable. To run the executable, you can just give the path to it. Now you can move that wherever you want, that executable wherever you want. So if you've got some place in your path statement where your software is installed, you can put it there so that you always have access to it. Otherwise, you can just leave it in this folder and run it right from there. So when we run Paladin, you see a few commands here. You see the index, you see prepare, you see align. These are the three main options that you'll be using when you use Paladin. Before you can align your reads and characterize them, you'll first need to build a reference and prepare a reference. Now that's kind of what the prepare command is for. It does that for you. Now if we just run Paladin for a second using the prepare command, it's going to tell you all the help options available with using prepare. Now this is geared towards using this with the Uniprot databases. So these are the default protein databases. You can use other ones, you can use your own, and if you have a different protein database you like working with, or if you have one you've made yourself, you can work with that as well. For today's tutorial, we're just going to work with one of the Uniprot databases. In this case, we're going to work with the SwissProt. It's a smaller database, so it'll be a little easier to work with. So The first thing is I'm going to run Paladin, prepare, and then I want to work with the Swissprot database, so that option is -R1. That's actually going to download the database automatically and index it. And when I say index, it means it's just going to prepare it and get it ready for use with Paladin. So let's do that, and as you can see, it's automatically downloading right now, and when it's done, it'll start to prepare it, so let's just wait. Okay, so the downloading is complete. It's starting to index it right now to complete the preparation step. It'll tell you each step of the way what it's doing. Now, depending on the size of the reference, this can take a vastly different amount of time. So for using the Swissprot's a fairly small database, so as you can see, it takes maybe a minute or two, depending on the speed of your computer. When you use something like UNRF90, you are going to need a lot of RAM and a lot of time. So the UNRF90 is more geared towards running in an HPC environment. You may need up to something like a day or a day and a half to index that, since it is a much larger database. And you will need a good amount of RAM, so at least 512 gigs, somewhere in that ballpark, depending on the size of the version of the UNRF90 that you use. Now, one thing you can do to make that a little easier to deal with when you are working with a large reference database like that and you don't have that much time or RAM, you can pare the database down and remove things like eukaryotes or other species that you don't necessarily care about in your characterization. Okay, so a few minutes have gone by, and you can see that the process is completed. It will tell you each step of the way how long that takes, just so you can plan for the future if you ever need to reindex another one, how long it's going to take on your computer. So at this point, if we look at the files in the directory, we're going to see the Uniprot database that was just downloaded, and you're also going to see a number of additional files that Paladin creates. These are the actual index files, so you're going to see things with like a BWT and a PAC and an AAN extension on them. Those are all the index files. Don't delete those. You'll actually need to keep those files, and you keep them in the same directory as your reference. You'll need that. Paladin will need those files when you go to align. Okay, so now that our reference is good to go, it's been indexed, we don't need to do that step in the future unless a new version of the database comes out. Once you've made an index of your reference, you're good to go. That's only a one-time process for each version of the database. So I already have some reads in this directory that I've prepared ahead of time, and that's this reads.fq file. And I want to characterize those. I want to see the composition of those reads, what's in there, what's the function of what's in there. So we're going to run Paladin again, but this time, instead of using the prepare command, we're going to use the align command. I'm going to start out by just running this with no options, and as you can see, it gives you the full help, and there are a number of options when running this, and don't be scared off by all these options. A lot of them are just if you need to tweak specific things, but there's only a few basic ones you need to worry about. We're going to be ignoring most of these. The ones that we need to worry about are the following. So first off, after you type the align command, you're going to give the name of your reference. So in my case, I'm using the Swissprot that I just downloaded. So that's that uniprot_sprot.facet.gz. If you download the UNRF90 and prepare that, it's going to have a slightly different name. And if you use a custom reference, obviously it would have whatever you name the file. After that, you're going to give it the name of your reads. Usually a FASTQ file, but you can also align FASTA files that don't have quality data associated with them. Now, just note that Paladin only aligns forward reads. So if you do have paired end reads, you'll just use the forward, and that will be fine for characterization. Okay, the few options you do want to worry about, -T is going to control how many threads the program uses, how many cores, how parallel it runs. So you want to, depending on the environment that you're running in, you want to match this to the number of cores you have. For instance, if you're running in an HPC environment, you want to use all the cores of the machine, or you want to use all the cores that were given to you by your job scheduler. If you're on your home machine and you want to leave some cores free for doing other work in the background, maybe you want to pare that down a little bit to a number lower than the number of cores. On this machine, it's lower powered, so it's only 6 cores, so I'm just going to specify 4, the number of threads to use. And then you want to do -O, and that's going to be the output file name. So it's going to create 2 files when it runs, a SAM file, which is going to contain the alignment data of specifying what read mapped to what protein, And it's also going to create a TSV file, which is going to be a tab delimited table, which is going to give lots of characterization information. So I'm just going to call mine output for now. Oops. Okay. So the first thing, it's going to load the index in, then it's going to run the reads through and align them. Now this is a smaller reset, so it's going to go pretty quickly. Once it's done, it's going to submit to Uniprot all the matches it found. So in this case, it found 171 matches. It's going to submit those to the Uniprot database to further characterize them, get back database cross-references, gene names, the taxonomy information, things like that. So now we're done. It reports out how much time it took to run. If we list files, there's our two files. We see output.sam and the output Uniprot TSV report. So let's take a look at the TSV report for a second. I'm just going to use less. Now, this is tab delimited data, so you can directly import this into a tool like Excel. If you have the tab view command line program, that can be useful as well. But just scanning through some of the columns to be aware of. Count is the number of instances of that protein it found. Abundance is a percentage of the total. You've got your mapping quality, which is going to be your confidence score on the Fred scale of how confident it was that the match is correct, with 60 being the max. It's going to give you the Uniprot KB ID, so what protein it matched to in the database. It will give you the full name of the species. It will give you some gene ontology information, so all the Go terms, so if there's any gene ontology information associated with it. It'll give you database cross-references into Patrick, into Ensemble, and a few others, and it will give you the full taxonomic lineage. So if we kind of go to the end here, we can see, oh, here we have the Pseudomonas, and it'll give you the full taxonomic lineage all the way up, gamma proteobacteria, bacteria, etc. So it gives you the full taxonomic lineage all the way for everything that it was able to identify. One thing to note, when you are using this data for your analysis, definitely filter it by that mapping quality. You are going to see some lower values in here. So even though this one has a lot of 60s, we can see a 13 here, you'll get some zeros. In those cases, you really want to filter those out. So you want to filter on your max quality and get rid of anything that isn't at least like a 20 or 30 or above. It depends on how stringent you want to be with that. Also included is the SAM file. This is more useful. You can view this directly, but this is more useful for using with tools like SAM tools. With SAM tools, you're going to be able to get a percentage of the reads mapped and some other information. So let's just run that real fast. SAM tools. We're going to use the flag stat command, and then we're going to give it that SAM file. It just takes a second. And as you can see, this is a smaller read set, but we can see, okay, 189 of my 961 reads mapped successfully. That's 19%. And if there's anything more, a lot of these statistics aren't going to be filled in because of the nature of the protein mapping, but the biggest is that percentage of reads mapped, so you can kind of get an idea of how well all your reads mapped. Now, addition to directly looking at the TSV file and using SAM tools with the SAM file, there are some downstream analysis tools specifically built around Paladin called Paladin plugins. I'm going to cover those on a different day, but if you do want to kind of delve into those, they're available on the same GitHub site as Paladin as well. So I do want to explore one more option associated with Paladin. This is especially important if you're going to be using a custom reference. So there are two styles of using a custom reference. One is any protein reference you want. The issue comes down to if you need to get back that Uniprot characterization info or not. If you don't care about that and you only need the SAM file, then you're free to use whatever protein database you want. You don't have to worry about the FASTA headers. They can be in whatever format. It'll work fine. So in that case, you're going to use the Paladin index command. So for Paladin index, it takes any kind of reference. It's going to take a protein reference by indicating R3. You can also give it a nucleotide reference with a corresponding annotation file, like a GFF annotation, and it'll extract out the CDS coding sequences from that and build the reference using those. If you have a reference that is built using the Uniprot style headers, however, you want to continue to use the prepare command. This will give you access to getting that ending TSV file. You'll always need to use the prepare command if you want that TSV file. When we use prepare, we have this option of manually specifying a local reference database. So in that case, we're going to use prepare like we did before. But we are, this time, going to specify, in addition to R1 and R2, we're going to specify -f and then the name of our local reference. Whatever the file name is, you're going to put that there. The headers will have to be in the same format as one of these two styles. So they'll have to either be in SwissProt format or UNIREF 90. Depending on which format you put your headers in, just change that R1 to R2. But otherwise, you can use a local version that you made that includes versions where you've removed species that you're not interested in to make the database smaller. So that's pretty much it. Paladin's actually a pretty straightforward tool to run. Once you've downloaded it and prepared the reference, it's really easy. You just run that align command. Just be aware that obviously, depending on the database size and the number of reads you have, it can take a while. The more cores you have, the better, but you don't always have access to a lot of cores, so just keep in mind that you'll need to allocate some time for your analysis to finish. So hopefully you found the Paladin information useful. If you did, please like and comment below, and don't forget to subscribe to the channel so you can catch all future tutorials. And let me know in the comments if there are any specific topics you'd like to see covered in the future. Thanks for watching, bye for now.